Hello, and welcome to Advanced Manufacturing Now, a podcast for manufacturing professionals. I'm your host, Steve Plumb, Editor-in-Chief for SME Media, along with two of my favorite cohorts, Kip Hanson and Amy Bryson, who I know would be remiss if I didn't remind everyone to like and subscribe to the podcast and make all of their friends and family very, very proud. So happy Friday, everyone. It's a beautiful fall-like day in early September here in Michigan. How's everything in your neck of the woods, Kip?
It's real good. It's finally cooling down a little bit.
Great. So we're here to talk about the October issue of Smart Shop Essentials, which is at the printer today and should be going out in the mail shortly. And this issue is focused on metrology, which in layman's terms is the study of measurement. But Kip, as our resident expert, can you give us a little bit more insightful description and how the field has progressed in recent years?
Well, yeah, like anything in manufacturing, it's gotten a lot more technical over the years. A lot more reliance on as you'll see in the October issue, on machine probing and relying on the machine tools. Really, we could have talked about micrometers and dial indicators and all that, but everyone knows about that already. This issue focuses more on, like I said, machine probing, software systems, the importance of getting your machine tool properly calibrated so it can make good parts, and a fair amount of automation in there as well.
Yeah, so talking about calibration, I know, Amy, you had wanted to talk a little bit about Dan Schoolin's article.
Yeah, Dan Schoolin, who is the head of metrology solutions at Renishaw, he contributed a really insightful piece called Why Calibration Matters. And Dan says that achieving precision in manufacturing, it doesn't really require you to have like a full metrology lab or a huge team of experts. Instead, he says it really requires a shift in your mindset to think about building and maintaining trust. And that's trust in machines, trust in your process, your people, and the parts that you ultimately deliver. And Dan says that to build that kind of trust, the most effective path is through calibration. And one of the areas he touches on is cost versus value. And it's natural to think about the cost of calibration. But the real question is, he says, what's the cost of not doing it? It's not just like a machine's out of spec producing bad parts. It also wears tools faster, wastes materials, and ultimately wastes time, which equals money. So related to cost, Dan also says that calibration doesn't require a huge investment. You can start with a single machine and build from that point, which really ladders up to something that we talk a lot about, which is smart manufacturing. And Dan asserts that calibration is really a foundation of smart manufacturing. It allows real-time monitoring and automated quality control, and it's about the entire production system to ensure that all these digital systems are grounded in physical accuracy. And this is especially important for shops that maybe haven't yet achieved, a high degree of automation. So calibration does allow for making better decisions and gives you a place to start for more effective troubleshooting and get an understanding about where improvements can and should be made. And as we know, manufacturing is becoming more connected and data-driven, and calibration then becomes even more important. So if you can't trust your process data, if your machines aren't accurate, you can't automate inspection if you don't know what your baseline is. And so this all ties back to smart manufacturing. So make sure to check out the article and get some really, smart, actionable guidance and recommendations that are relevant really for shops of any size. And speaking of good advice, Kip, I know that you have some good stuff to talk about related to machine probing and the article Cut, Probe, Cut.
Yeah, so Cut, Probe, Cut is a article with Mazak, one of the applications engineers turned salespersons, Jason Taylor. He talks about, it was actually interesting to me because I've known of probing and used probing for probably well, 30 some years now it's been available. And I think now it's finally starting to get some traction. And Jason talks a lot about, he offers some advice on using probes on the machine tool, not just for setting up and for touching off tool links and all that, but to run the machine autonomously via the probe, where you can come in there. And it's the same thing a machinist does when he or she is setting up a job or checking parts in process. They stop the machine, get in the micrometer or what have you, bore gauge, and measure the part, then make an offset. Um, Jason argues that the better way to do it is to go ahead and use the machine probing, which most machines have now. Take a cut, leave an extra few thou on the part or the feature that you're trying to measure. Get in there with the probe, check the part, look at the measurements, and then the machine will automatically go ahead and make an offset for you, or you can do it yourself, and then go ahead and continue cutting the workpiece, finishing the part. But there's also a lot of other advice in there about the programming probes these days is a lot easier than it was 20, 30 years ago. You don't need deep macro programming skills. It's pretty much plug and play these days. So it's really encouragement to use the probing system if you've got one, and invest in one if you don't. And even if you're not ready to go lights out, it can certainly save you a lot of time on machining. Especially these days, operators are charged with running multiple machines at one time. So using your machine probes will save you a lot of time and grief downstream. And then another story we had from Hexagon, Stephen Graham. You might think of it as a QMS system, but it's not. It goes a lot farther than that. He's talking about his Nexus, the Nexus platform that Hexagon has. It resides in the cloud and automates a lot of the inspection routines, standardizes inspection routines, and makes it a lot easier for maybe less skilled workers to use, and at the same time helps to standardize across the shop floor. So I guess his message is that it's not, quality isn't just a checkpoint. It's kind of the central hub around everything in the shop, from training to throughput on the machine tools. And that he makes a statement that it eliminates the bottleneck that so often appears with the standard inspection. And you can tell that from the cover of the magazine, that people staying in line waiting to get their parts. He makes the argument that by investing in the right software system, that you can eliminate a lot of that bottleneck.
Yeah, and that's a perfect segue into the other article from Dylan Kutel, a regional sales manager at Zeiss Industrial Quality Solutions. And it's a problem that I know Kip and Amy may run into, me not so much. The downside of being too good at your job is that word gets out and suddenly you're loaded up with an insane amount of work, which of course can create these bottlenecks and stress. So the same thing can happen when a shop buys a coordinate measuring machine or CMM. Everyone and their brother wants to use it all the time for everything. And Dylan describes the scenario and how to beat it. The solution, he says, is to use a shop hardened CMM that operators, pretty much anyone on the shop floor, can use directly where they are, rather than having to wait in line or turn it over to the inspection room professionals. And when they do that, they're leaving their own machine idle, which reduces efficiency. So as Dylan notes, bringing the CMM closer to the part is only the first step. Advanced CMMs are also boosting throughput, streamlining the quality control process and increasing ROI. A winning trifecta for any shop, and frankly, a lot better odds than hitting the lottery. With a CMM on the shop floor, the QC department can better focus on resolving higher level issues while operators handle the routine measurements. Of course, not all CMMs are built the same or up for a job on the shop floor. They have to be extremely durable for starters, with mechanical bearings, and they have the necessary covers to protect against dust, debris, and grime. And perhaps most importantly, they have to be compact enough to fit in between existing equipment and still allow people to maneuver around it. Other considerations include fixturing, namely zero-point units that enable quick change capabilities. And as is the case really for many shops and plant equipment, partnering with industry experts is critical to properly choose and set up any CMM, as well as train employees and provide follow-up service. Of course, Zeiss is one of the leaders in this field. Dylan goes on to talk about the benefits of advanced automation, dual pallets, and other features designed to help shop personnel. In some cases, this means fully automated systems, which use robots to transfer parts between the CNC machine and the CMM. I really encourage everyone to read this article and frankly all the articles in Smart Shop Essentials for more useful tips. Kip, any other thoughts on the metrology issue?
No, I just want to touch on what you were just talking about, the shop floor CMMs. I mean, it's really kind of been forbidden for a lot of years. CMM is typically used in a metrology room where it's environmentally controlled and temperature controlled, and some of the shop floor CMMs, well, all the shop floor CMMs now, they come with thermal compensations. You don't have to worry about the temperature swings. And going back to what Amy was talking about, a lot of times you can actually use the machine tool to measure parts in process, but it depends on having the machine properly calibrated. And one thing that Dan Schoolin didn't mention, I'm sure he'd love to talk about it, is their Equator product, which it's not a CMM, but it's the Equator system. It uses a gauge for a known part as a standard, and it allows you to do a lot of what the same thing shop floor CMMs do, even though they don't call it a shop floor CMM. So take a look at the Equator if you're in the market for that. It's a good solution.
And you really drive the point home in your column, which we didn't talk about, which kind of sets the tone, but saying that even though we've covered a lot of territory, we're only scratching the surface here on the value of metrology and CMMs. And you quoted one figure from the American Society of Quality that true quality related costs as high as 15% to 20% of sales revenue, some going as high as 40% of total operations. Getting it right the first time really helps out.
Yeah, that's a crazy figure when you stop and think people are focusing on reducing their cutting tool costs and kind of not seeing the forest for the trees.
Well, thanks, Kip and Amy, as always, and we look forward to talking again with the December issue, which I know you're working hard on right now, Kip, as we speak. And to learn more about the latest manufacturing trends and hear more of our podcasts, visit advancedmanufacturing.org and be sure to like and subscribe to our feed.